So reiterating it, I mean, we are just initiating the advanced discussions on the classes. So let's start our journey, and let me configure the pointer. Okay, here we are. So, the instance variables are, I mean, when you talk about the instance variable, that means those are member variable in a class. Each object has its own copy as well. So basically, what you know, I mean, what you can do here is, let's create a new file. Let's create a C++ file. So let's say uh, test1.cpp, and if we okay, so if we create that file, so basically include IO stream, and then using uh, namespace std, and then comes the definition of the classes. I mean, we can start with very simple definition of the classes. We don't have to be very we don't need to be very comprehensive in terms of the class definition. I'm trying to find out a simple definition of the classes from our examples that we have already worked out. So let's say um, we have a class called, let's say, class student. I'm just making it up, student, and then we can, as the convention goes, we put a curly brace, we put a semicolon, and then we can write like private. Then you can just put some variable declaration, int student ID, and then you can have the public. I'm just giving you just one simple example, just to recap whatever we have learned before. So there you can do just in the public, let's declare a constructor called student, and if you remember, the constructor name has to be the same as the class name. So if it is like that, let's say we do student ID equals 0, that means we are initializing the student ID, and then we can do something like int uh, get student ID, that is the accessor function, if you remember. And we are defining inline, we are not putting any out of the body declaration of the variables. So return, you can say student ID, and then you can have a setter function as well. So that should be a void, that is it should set up the variable. So set student ID, and int student ID is there. Then you can just do, so you can say this is capitalized, and you can say a student ID, that is the argument, let us say. So you can tell this variable student ID equals the equals a student ID. So that is the complete definition of the class. It's a very simplest primitive form. This is the definition of your class. Now, you may ask the question that, well, we have the class defined, then what is the instance variable in the class? What is the terminology all about? So this is the member variable. In our case, this is the instance variable. Student ID is the instance variable. So why do you call it instance variable? That's another question. So let's say we are using this class, and in order to use it, let's say we are doing it here itself. Let's say we do uh, that we have to define some function, some arbitrary function. Let's say int main, and then we can say uh, we can instantiate the class. So that is you can say student S. S is the instance of the class, and then we can say that uh, basically whenever you instantiate the class from our previous lessons, this part of the code should be executed because this is the constructor, and then we can say S set student ID, let's say 100, and then if we do cout and then S get student ID, then you should be able to print, right? So that's it. So if you run this program now, let's say we let's create a new terminal, and then G, GCC is the compiler that we use, dash O, then we can say test1.exe, then test1.cpp. If we do that, we have a little bit of problem here. Let's see what's going on. Probably we are not doing it correctly. Something is off. Maybe G++, not GCC. Yeah, no, that's not. So what's happening here? We have this is uh, what's wrong here? Uh, so we have this class defined here, and then we have the main function. Oh, we can do return 0. Let's do it outside the class. Maybe that's what is causing the issue. Let's create another file and call it test.cpp, and then under test.cpp we can put it like that, and then of course we need to do, but we don't have that I mean that .h file, so we did not define .h file, so we can have some problem here. We do not need to do that at all. So let's stick with this plan itself, and then we can restore this one. There is some problem here. Let's solve this problem. So here we have namespace include, that is fine. You have the class student, so we have defined the class, and then what is the problem then? We have let's say we are doing that, and then undefined reference to main. Okay, so what is happening? Why the main is causing the issue? So let's see. We don't have any problem here. Let's do a little bit of more work here. Let's define it. Let's take it outside of this one, test1.h, and let's define it here. Everything here. Then it is a more cleaner approach. So let's get rid of this, and then we can do sorry, include here in the top. We can say include then test 1.h. So that is it, test 1.h, and then we can save it. So why the student is not identified student is undefined? Why it is saying that? It should be here because you have the class student. Let's see what is happening here. So you have the class definition. There is no problem in here. So you have private int public. It is good. It is good. So it is good here. But then yeah, now it is good. So now if you try to do that, let's say test1.cpp, that's fine. So student was not declared in the scope. So what is happening here? Why the student is not declared in the scope? So let's see what is wrong about this main function. So we have S, that is fine. Student S is fine. Um, So what is going on here? So it's a very simple example. It should not, we should not have problem here. So you have it here. You have student, and then you have test1.cpp, and it is as if it is not finding anything anywhere. What's wrong? So, oh, I think test1.h is not saved. Probably that's the reason. And we save it here. Now, if we do that, now it is good. So it was not saved. I did not save it. So test1.exe, if we run it, you can see that. So what's wrong here? Oh, sorry. Test1.exe should be here, and then you can see 100. You get 100. So basically, what is happening here? So this is .h file, and uh, we basically set the instance variable using the mutator function, which is set student ID, this one. And then, I mean, you can have multiple instance of this class. I mean, you can declare multiple instance of the class. If you declare multiple instance, each instance has their own set of instance variable. For example, if you set up another instance of the class, let's say I'm just copying and pasting everything here, and let's say I call it student S2. There is another student, another instance of the student, and their ID is in right now it is 101. Then if you do S2 here, then if you execute this one, so we have to do that, and then if we execute this one, you will see that there are two students created, but when we get the instance variables, they are 100 and 101. So what did we learn from here is very simple, because a student, this class has an instance variable student ID. Now why we call it instance variable, because it is really tied with the object that you create out of this class or out of the instance of this class. So once you instantiate it for the first time here, you call it S, and then you set the student ID to be 100. That means you are setting this number, this student ID to be 100, and this 100 is different from the one we define here as 101, because it is a part of another instance. So these variables are really tied with the instances of the class. That's why we call them instance variable. Okay, so that's our instance variable, and each object has its own copy. That's what we saw. I mean here, S1 and S2 that we defined, this has one copy, S2 has its own copy. So that's how things are evolving here. Now you can also define the static variables. That is one variable shared among all objects of the class. This is a different concept. So static variables, when we talk about the static variables, we really, what we really say there is basically these variables are, uh, I mean, they don't belong to each object separately. They are not instance variables. They belong to the whole class in the scope. So, I mean, they are basically, the bottom line is those static variables are never an instance variable. Okay. So let's try to find out some examples of the static variable as well. So, just a second. Okay, so let's define for that purpose. Let's do this. I mean, I'm just borrowing the same example which is referred in your book, textbook. So let's say we are defining a new class which is called tree. Let's define a class called tree.h. This is a header file, and our definition is pretty simple here. So we call it like this. So what does it mean? This is the class. Tree is the name of the class. You have a private, but you have a static variable, integer object count. It is basically tracking the how many objects are being created here. Now you have the tree, I mean, you have the constructor where you are, once you construct it, then it is incrementing the object count by one, and then you have an accessor function for this object count where you are returning the object count with respect to this static variable. And I mean, you, whenever, or how do you define the static member variable? You the way you initialize it, you should define it outside the, I mean, this is written outside the class. So we basically say int, and then that this means object count is a member variable of the class tree, and we instantiate it to 0. So this is the basic outline of the static variable. So in if this variable were not static, then we would expect that each instance would have a copy of the object count. But in our case, this class as a whole, since this is a static variable, it does not go with the instance. It goes with the class as a whole. So then how do we I mean, how do we run it? So basically, let's say we do it in this way. We create another program and we call it, let's say, tree test.cpp. So we are testing the tree class, and then we can come up with something like this. So where we have included tree.h, but then you see we are instantiating three trees, oak, elm, and pine. There are three trees, and then I'm trying to get hold of the object count. So if we try to compile it, let's see, let's compile it first. Hopefully it does not have any syntax error. So let's say tree.exe, and then tree dot uh, sorry, tree test.cpp, because that's the one in scope. So that's good. Tree.exe, if we execute it, you see you have three instances because you have instantiated it thrice. So why, what is the, I mean, what's going on here? Why static variable is so important? If you don't use the keyword static in this case, let's remove it for the time being, and then let's say we uh, instantiate it here, and then let's get away with that. Okay, so if we do that, and then if we simply recompile it, you will get some different result. So here is what you get, because you get one trees in our program. Why? That's because of the fact that, each time you instantiate, this is not a static variable. So each instance has its own copy of this object count. That's why it is just incremented by one. But if once you make it static, then what is happening here? Um, Once you make it static, I mean, don't worry about this error. This will go away pretty soon. But once you recompile this program, then what happens? Once you make it static, then this variable goes as a whole with the class itself. Not It is not attached to the object anymore. So then you will you will simply find that for this class, in the life cycle of this class, there are three different there are three different occurrence of this object. But for each occurrence, we are incrementing this static variable each time it is instantiated. That means if you have three class, it will be instantiated thrice. If you have four class, let us say, so let's say um, guava, another uh, another tree is the guava, and then if we have, we should expect four here. I mean number of I mean this static variable object count should be 4 here, because as a whole we have created 4 objects and it is incremented 4 times. So let's see, if we run it, you will be able to see that uh, so you have 4 trees in our program. So that is the benefit of using the static variable. If you want to keep track of certain things, then you should define it as a static variable. So let's say we are, suppose there is a school information system and you have, let us say, 10,000 students enrolled in the school, and everything is encapsulated inside the class called student. Now you want to get the student count. There are a couple ways you can accomplish the student count. One way is simply just after each instantiation of the student, let us say, I mean, I'm just simulating some situation here. So bear with me when while I'm creating something to write on. So don't worry about this grayed area. So you have a student system. So let's say, why it is not. So this is your, let's say, student object. Okay, let's write it two for the sake of brevity. So you have a student object here sitting right here. Now, um, let's say a school has 10,000 students. Okay, so basically, in a very simple manner, I mean, very simple, very hypothetical way, we should be able to run a for loop, right? Over these 10,000 students, 1 to 10,000. I'm just focusing on pseudocode, not the real code here. So within that for loop, what you can do, I mean, let's say the requirement is you don't know the number of students. I mean, let's say this is n, right? And this n is given by the users on the fly. So what can happen, you can say instead of 10,000 you can write, do it n, so you don't know how many, really how many students are there. It depends on user to determine. So in this for loop, there are two requirements. You can set, you have to set certain member variables, I mean instance variables for the students. Let's say grade, whatever, I mean the final grade, everything, the final grade point average or GPA, final GPA, and so on. I mean those member variables. We are not talking about constructor. We are not talking about accessor mutator, because I assume that we are all understand that. So in the student object, what is going to happen? You have to keep track of the something global to all student. Maybe the school wants you that you create an average. You give you some average of the GPS obtained by all students. So then the best way is to define a static member function here, static integer, just the way we defined it in our previous example. So you can do a static int some student count, int, let's say int count, and also static int, or not int, it should be float. GPA should be float, float GPA, GPA, and then another static float average. This average is the average GPA. Now you do you do the in the for loop, you are, I'm assuming that there will be um, this is the float GPA. This is not static float. Let's say this is float GPA. So what we are going to do using the mutator function, we will be setting the GPA within this program. So set, uh, I mean, let's say there is an instance of student. We instantiate the student here, student S, and then set GPA to be, let's say, I mean, it depends on whatever. Let's say there is an array of GPA, so we can say in J. J is the index of this for loop. So according to the J, I mean, we different student get different GPA. So for each for set GPA we have, and then we can create a function that will basically, um, I mean, we can define a function, simple function that will simply count the GPA once the student is created here within the constructor, exactly whatever we have done in the in case of tree student, let's say here we will be doing, or I mean, maybe some other function, we can define some other function, get GPA average or something like that, and there we will be adding up the GPS and adding up the counts. We can do the counts can be added up here, and GPS can be um, added up somewhere else. I mean, wherever you do the set GPA, there you can do another variable which will be basically the sum of GPS, and that way what is going to happen at the end of the day, you can, and always you can have a running average for the GPS for the school. So at the end of the for loop, once you are get out of the for loop, you should be able to print s dot average, you know, and that average will be the average GPA for all students. So that's the way you can derive lot of analytics out of a simple scenario. In this case, it is a simple class student, and we are not required to create any other boilerplate coding, like you keep track of, and you define additional variables and keep track of the running average of the GPA outside of the class. You don't have to do that. You can do it all inside the class. What is the advantage? The advantage is, maybe this student class is, I mean, it is built and it is well tested. Then you can use it everywhere. You don't have to worry about the client code. Client code means wherever we define that int main function, that is called the client side code. You don't worry about the client side code. You simply uh, create any arbitrary client side code and just run a for loop, and you will get the average running average as a output of that for loop, after that for loop. So that's the benefit you are getting out of it, and all these benefits are due to the fact that we have the capabilities to define the static instance variables. So that's one of the simple usage of that. Similarly, you can have static member functions that you can use it to access the static member variable. So, I mean, it can be called before any objects are defined. So there are examples. For example, I mean, this is the simple static member function. We already talked about it, so I'm just reiterating this. So you have this static member function, and then you have the static member you can define outside the class. You should not define it inside the class. Why? Because inside the class, everything should be belonging to the class itself. Everything should be member of the class. So you should define it outside the class and instantiate it, and then you can increment it inside the class. Whatever is dynamic, that can accumulate inside the class, but what is static, that should go outside the class. That's the rationale. Then, I mean, we already talked about this program. So in this case, they explained about different this static variable that has, I mean, basically there are three instances. That's how we get three object count to be three. Anyways, so there is another example, static member function. The static member function, how do you define it? I mean, from the syntax of the C++, a static member function should contain a keyword static. You know, this is a reserved keyword for C++. You cannot define a member function, member variable inside C++ code and name it static because it's a reserved keyword. What I'm saying is that you cannot write a C++ code and just say int static. Static cannot be a variable name. It's a big no because it's a reserved keyword. So you define it in this way, static int get object count. So basically what we are doing, what we are accomplishing here we have this one, and this object count is basically, I mean, we are accessing that object count as a part of our class, whatever we are coming up with. So Pine, we say get object count. This is the get object count. Where is this? Here. This is the get object count. So this one, and in this case, you could define it in this way. So if you define it static, what is bad with that? I mean, what is the difference between just int get object count and static int object count? The static member functions can only access static member data, you know, but this cannot access any out non-static member data. So this can be called independent of objects, and you can do it in this way. So you can just you can call it in that way, and that way it will be simple. I mean, why it is independent of object. Why I'm saying this? Because you are not accessing it through s dot get object. You are accessing it by defining the class itself. So it belongs to the class rather than an instance of the class. That's the main point here. I'm sorry. Okay, I mean, anytime you have any questions, please let me know. If you have any question, I will be happy to explain that to you. So that's the difference between. So we learned the difference between static member function and a simple instance member function. You know. So main difference is static member functions can only access the static member data. So, and you can call it independent of the objects itself. So let's try that one. What does it mean? So let's say we have the same thing going on here, and here what we are doing, we can do static. We can make it static, right? So we don't need to specify constant here. So it's static. So there is you cannot annotate it with the constant because it is by definition it is static. You cannot change it. So now, how do you access this one? So here, if you do, there is no problem in that method. Let's run it and see how it works. But there are alternative way you could run it as well. So if you do that and then you have four instance, there is no problem. But here, if you do simply tree and then just what is happening here? Must be related to this. A non-static reference must be related to a specific object. Oops. So, oh yeah, that should be here itself. So, so you can do it like that. and then you can do um, static int, so you can define it outside the class, get object count, and then you can do, so you don't need to do static here, int get object count, and you can say return um, tree object count. So that I'm making it little weird, but that's the way it should work. So you have, so what did we do here? So pine, whatever we do, it really doesn't matter. If we simply do it in this way, and if you run it, you will see the four. So it's little bit slightly different way of defining the things. It's basically, I mean, we are doing the same thing. We are running in the same loop, but we are doing it little bit in a little different way. That's the that's the small difference we made here. So that's about it. So that's our static member function. So then, I mean, it's like this, as we said. I mean, you could make it inside as well. But now they are claiming that you should be, that's what I thought too, but I don't know why it is not allowing me. Let's see, let's do another attempt here. So here we do this, and then we can go back here, and let's say we do, as they said, tree, this one, no dot. Well, a non-static reference must be related to specific object. So why I'm getting this type of error while they are not getting that error at all. So let's see. Let's see what is going on here. So they do it exactly the way we did it. We can do it. I mean, that's fine. That's not a problem. We can also put it inside of this. So like there is no big difference if we put it like this. Return object count, and then we get rid of this one. That's okay. That's fine. That's not a problem. But then they claim that, I mean, you have return object count. That's fine. Now you can call it in this way. So you have this one. So let's see how what is happening here. So you have it like that, and then you have tree test. If we try to compile it, do we get the same error? Oops, clear. And then let's do it again. Here you go. I mean, you don't get that error. Maybe it's, yeah, that's right. I mean, it is specific for the I mean, Visual Studio Code, the the active the compiler, the plugin that we loaded here isn't able to recognize these differentials in the code. But don't worry about it. It is going to work when you compile it with C++. So if we see what is the quick fix, no, that's okay. We can disable the error, so that's fine because it's not an error. That's why I disabled the error. So if you compile it and if you run it, it should be just fine. And you have four trees, and it is more graceful because you are accessing a static function in a static way. So that's the best practice. Whenever you have a static function, you should access it in the static way. You could define a member function as well to access it. It's up to you, up to the programmer on how to do that. So that's about the static function. Then the next topic, let's roll on to the next topic, that is the friends of classes. These are all very, I would say these are all, I mean, majority of the syntaxes within the class definitions in C++ we already covered. These are all edge cases. I mean, the different advanced cases where a class can be used. The usage of the class can be extended. So a friend of classes, a friend means, what does a friend mean? I mean, let's say there is a family and you can have a friend for the family. So does that friend belong to the family? I mean, their friends are not family member, but they are friends, so they have access to some information of the family, right? Because of the closeness, I mean, because of their relationship. So if similarly in the programming world, we define a friend function. So a friend function or class, you can have a friend function, you can have a friend class as well. Uh, this is not a member of the class. A friend function is not a member function of the class at all. So it's not a member like a family. A friend is not a member of the family, but has access to private members of the class. So they have access to, they may have, I mean, friends in the real world. If they are very close friends, sometimes they do have access to personal information of the family members. Now, a friend function can be standalone function or a member function of another class. It is declared a friend of a class with a friend keyword in the function prototype. So this is a very important, I mean, step forward as far as the programming goes, you know. So let's try to get some example. Um, so let's say we are trying to simulate some kind of budget. Let's define a budget class. Let's start. I mean, that is, I mean, I'm following the lead of your book itself, so that when you read it, when you read the class lecture or listen to the class lecture, they look same, they sound same. Budget.h, I'm creating this class, and the definition of the class can be like this. So this is our budget class, you know. So what it contains, it starts with the class syntax budget, then the private member, you have the static corporate budget, it's a static member, double division budget, then you have the budget. So corporate budget is basically a constant. I mean, you cannot change it. It is beyond the control of the division. But then you define the constructor here, and then you have add budget, whatever you are trying to add it. And then whenever you add the division budget, you have to add that to the corporate budget as well, because as you change your division budget, your corporate budget will be affected. And these are the uh, accessor functions. This is the mutator function, and then you define it outside the outside of here. Okay, so I haven't seen any trace of friend here yet. I mean, it's a simple uh, simple static, I mean, the static member function. Static, we defined simple static member functions of the class, you know. So uh, now we can make it little bit advanced, you know. So what you can do here, um, you have this one definition of the static member, that's fine. So that's not a problem. So we can do a different, we can do it in a little bit different way. So you can have the division budget to be 0, but yeah, it can stay here. Now let's talk about some member function. Okay, so what we can do, um, let's say we are we have this company has a simple, I mean normal office, the 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 regular office, and this on the top of that, this company has a auxiliary office as well, let's say. So, I mean, I'm trying to make things little complicated, not over complicating stuff, but making it little bit complicated. So that's the scope of the, that's the scope of the friend function. So what we are going to do, um, let's change it in a little bit. We will change it. So let's say we have an auxiliary office for this particular company. We can say AUXIL dot H. That is the auxiliary like auxiliary office definition. So we can make it in this way. So what is happening here? Uh, it is it's a we define the class budget, and then we have the class auxiliary office, and class budget is defined inside your budget.h. So we are good there. Now we are defining auxiliary office, and then we have this add budget. Now this add budget is not, you see there are a couple of member functions. Number one is get division budget and accessor, but there is a mutator which is called add budget. So how do we define it? So then comes the scope of the friend function. So our friend, our budget.h needs to be little bit modified to accommodate this one. Let's say now we are thinking about, we have a we have a main office like corporate headquarter, and we have an auxiliary office. Okay, so let's do it in this way. Um, let's say we put it like there is a static member function we add um, here. We call it main office. That's the main office, and then we can add a uh, friend function here, which is called uh, auxiliary office. So this auxiliary office, let's make it little even from the syntax. This is not yet defined, but this is defined. Where it is defined first, it is defined inside, where is it, here. So now you can see that I don't know why it is not showing the definition not found. We'll see. We'll take care of that. But in the budget.h, we are also like we make this function as friend function, because what is the benefit we are getting out of it? Because within the budget class we are defining it, we are ensuring that it is a friend function. So this auxiliary office will also be able to contribute to the budget. So a company has multiple branches. So each branch is enabled to contribute to the budget so that everything adds up to the corporate budget. That's the main goal here. And here we of course used the budget to be the pointer. I mean, we use the pointer notation to make things little clear to it. So now let's do some implementation, add budget implementation. So for that, actually, we can simply define another simple function called auxil.cpp. I mean, we already uh, know about this implementation uh, of the functions, so we can define it in this way. So simply we are saying that auxiliary office, we are defining this add budget, and we are calling this auxil.h. So now we can see inside auxil.h, this one is not showing up any warning, because we have already defined this function. It's a very simple function, and but only thing is that the budget is just referenced to be the reference variable is div, and we are just adding, it is allowing us to add to the corporate budget. That's simple. So now we have to define the budget class as well. So in order to do the budget class, let's create another class here, budget.cpp, and we can define it in this way. Now you can see that we can go back to the budget.h and we can comfortably delete this one, and we can export this initialization here. I mean, we could keep it in the .h file as well, but .h files are not really for writing code. It is writing the definition. It can be used as .h files can be used as the API. So whatever code we are willing to write, we should be writing inside the C++ module. So that's the best practice, one of the best practices in this case. So we have defined four classes, budget.h. In the budget.h, everything is simple except we define here auxiliary office as the, I mean, this add budget of auxiliary office class as the friend function. Now, then in the auxil.h here we have declared the budget class so that we can use it moving forward. So and then we define the add budget class here. And here, if you do auxil.cpp, you have defined the add budget class. It's no brainer. It's very simple. And then the budget class also defined. We instantiated the corporate budget here, and simply for the main office, that's what we defined in our budget class, the main office, which was not yet defined. I believe that we made uh, s- some spelling mistake or something like that. Budget, yeah, that should be fine. Why it is causing issue then? You have budget.h. So if you have budget.h, you have this one. Yeah, now it's good. Probably there was something wrong with saving the files, etc. So we have completed the loop. So we have everything in place. Now you can just run the program simply. So let's say, uh, just a second. So we want to run this program for different auxiliary office as well as the main office. I'm just trying to figure out how we can demo that successfully. Let's see. So you have the budget class, that is good. And then you have different divisions as well. I mean, that's fine. So you have auxiliary, this is defined. So, um, so you have here budget class, you have the auxil.h. So we have to use it so that we can define the budget class and we can define the usage of the auxil class as well. Okay. So let's try to run it in this way. Let's create another the client program basically. We can say uh, let's say the name of the program is um, budget allocation .cpp. That's the way we are allocating the budget. That's how we are defining the budgets. So if we do that, then you can see here, let's go through line by line in the code. So you have this include function. We'll get into that IO manip. We'll get into that. But we included the budget.h, and then we have the count. That's the loop counter basically. So there are four divisions, let's say, in the office. So we are talking about four different divisions. So we will be looping over those. So you have the main office and then you have four auxiliary office. So auxiliary office, this class This is essentially used as an array. Okay, so you have different auxiliary office. So then we start up the count. So number of divisions is 4, and then we have this double count to hold the input basically. So then you can do you are entering stuff here. So you have the budget amount, and then you are just adding, you are doing the add budget. So basically every time you call it, what is happening, divisions count. So divisions are defined here, you know, they are instantiated here. So divisions for particular index, you are adding the budget to it. So you are basically using this one, this function. So as a result, at the end, you have, uh, I mean, get the request for auxiliary office. So you have like enter the budget request for that division, and then auxiliary office, you are putting the amount and you are adding the budget. So that's the loop. For each one, we have one request. So you have one main office. So main office is handled in the beginning of the code. So now you have four different offices. Then you have different, different allocation requests. Then, you are displaying the budget requests and corporate budget. So you have, these are for basically formatting. That's why you need this IO manip header. That's the different stuff. It's related to formatting of the output. So now if you display it, you can run, you can do another run of the count variable. You can reuse the same variable because you are initializing it here. Then you do the divisions, you are incrementing count by 1. Then you have the divisions, you are just get the division budget. So it is you will get it here, get division budget here. And then once you do that, then you come to the auxiliary offices. For the auxiliary offices, you have the same thing. um, Same division budget, same thing is written here. So you get the division budget, then you are counting the total budget request. So you are just adding those, and then you are adding the corporate budget. You can use any of the divisions to extract the corporate budget. We have decided to use the first one because at least one division should be there. There can be multiple, depending on number of divisions. If you get here one or two or three, whatever it is, this total, the return value of this function will not change. So that's pretty much it is. So if you want to compile this program, you should do g++ dash o, and then let's say budget allocation dot exe, and then you have to mention all the C++ codes, auxil.cpp, budget.cpp, and then of course the last one, this one. Lot of errors. Let's see, friend used outside the class. What's going on here? In file included budget.h. Let's see what's wrong in here. So maybe something is going on here. I think there is some simple. Uh, let's see what's going on here. Yeah, I'm. We should be defining them inside the main body of the class. That way, things should be easier to define. So now, if we compile it, we have only one problem, has not been declared. This add budget has not been declared. So where is the error? Budget.h.cpp. So let's see, line number 25, auxiliary office has not been declared. So did we declare the auxiliary office? We forgot to include it here. So that's the reason we are getting the error. So we have to include auxil.h, then we have everything here, I guess. So if we now retry this one, So now we have different stuff going on. Oh, the main program. So let's see what is going on here. So we have it here. That is fine. Budget allocation.cpp undefined reference to win main. So basically the main function is not getting declared. I'm sure we are not saving things properly. That's the reason we are getting these errors. Let's see. Let's save this one. Let's review this one and save this one. So this is good. Auxil.h, you have this one. So I believe this is also good because we are saving it. Let's save it. Make sure we are saving it. Now budget.cpp, are we saving this one? So we are saving this one as well. Now budget.h, we made some changes here. So did we save this one? Let's see. So maybe we screwed up this class a little bit. So let's replace it as a whole with a good one. So there is no change. Basically, we just made it a little bit even in terms of like spacing all this stuff. So let's save it as well. Now budget allocation, do we include everything? Did we include everything? Let's see. For the budget allocation, I'm sorry. So we have looks like we have included everything. So I believe that we should be able to compile this time. No, still we have the problem. So what did we do? Auxil.cpp, budget.cpp, budget allocation.cpp, and then it is not finding the main function. So what is the root cause for this one? Let's see. Um, budget allocation, budget, auxil. No, no relief. So this is in function main. So what is going on in function main? Undefined reference to in main text startup. Oh, what is the error? What the error is going on here? That's pretty frustrating. I mean, let's see. This is the main function that we defined, of course. So if we just try to compile, let's say budget allocation.cpp, we get multiple errors, right? I mean, let's clear it, clear the output. So then if we do that, we get, so here we have everything. I mean, there is some problem with this particular uh, function itself. So let's see what is the problem with this one. So you have this one, this main function is clearly defined and return is clearly defined. Last time it was just missing, yeah. So it was not saved properly. I had to do control S multiple times. So it's a saving slash syncing problem between VS Code and our my disk drive. So yeah, that's pretty unusual. Anyways, let's try to run this program. Budget allocation.exe. So if we do the main office budget request, let's say $1,000, that is $200. Like let's say auxiliary office, let's say $100, and then budget for division 2, $200. Auxiliary office, let's say $207, $107. Division 3, let's say $3,000, and auxiliary office maybe $1,000. Then division 4, let's say $5,000, and auxiliary office, let's say $1,000, $1,002, let's say. So everything adds up and you will get this budget, total budget, and you can get all the different, I mean, every division's budget separately. So that's the So what happened here is basically we demonstrated two things. Number one is static member function stuff. We also, I mean, we use the static member function here, this one, and as well as we are using the friend function. And you can see here clearly how you define a friend function. I mean, you have to include it inside the class. Like a friend, you can include them inside the family, but they are not family members. Same way, you are including a friend function inside the main class, whatever. I mean, in our case, it's a budget class, and then you can drive your calculation out of that. And finally, we got that main program, the driving program, and that actually gives you all the ability to add the budgets to main office and their auxiliary of main office, and then the divisions along with the respective auxiliary offices. So that's basically a demo for the friend function. Any question? Okay, so let's give a break right now. Let's break for 10 minutes and we will come back and we will go through a little bit faster. We'll go through the remaining part of this class. So, yeah, let's get started after the break. So, it is we have discussed already the static member functions and the friend function. So, let's move on. Now, I mean, you can define the friend function in two ways. You can have a standalone function. Uh, that's what we did not do. But you can also define the member function of some other class. That's what we have done. So there are two ways basically you can define the friend functions. So when you have a friend class, I mean, if you call it a friend class, then you have a uh, basically a class that is a friend class, and you have to define the main class. Whose friend class is this one? So you have to define them in that way. It really doesn't matter where you are defining, so long as you are including the header files properly. But this is the way you should define a class to be a friend class. So it declares that entire class, friend class, as a friend of this class. So this class has basically access to all member functions of this particular the new class. So this is an amazing thing. I mean, you won't find this type of situation in any other programming language, mostly within my knowledge. C++ offers you to define a friend class. Also, you can define a friend function in that way. So let's see what is the member-wise assignment. So you can use equal sign, equality sign to assign one object to another or to initialize an object with an object's data. So you have object 1 and object 2. So if you have, you can simply put like this one. I mean, these are the object 1 means this is the instance of a class, and then this is also an instance of a class. So you can simply define this object 1 to be equals this object 2. So um, when you do that, it copies member to member. So it copy all member values from instance 1 and assign the corresponding member variables to instance 2. So you can use at the initialization itself. So let's say I mean, in our old example, I'm not just trying to write a new code anywhere. So let's go here and let's try to make up something out of this tree. So you have the tree test now. Um, let's say, or not even tree. I mean, we started with the student, right? Test one. This is the student. Yeah, that's good enough. So you have test.h and this one. We don't need this one. This needs to go away. So what? Let's delete this one. Okay, that's good. So this one. So let's say you define the student S and then you have this one. Now what you can do, you suppose you want to define S2 to be equals S1, you can simply do this and then if you do cout S2, sorry, get student ID, you should be expecting exactly the same thing. I mean, exactly 100 here. So let's try to test it. So what's going on? S1 is not declared. Oh, sorry. Should be S. S2 equals S. And then if you do that, dot slash test1 dot exe, if you run it, so you can see that member to member copy has happened. So basically S2 is a copy of S1. S basically here. So the the object that we are creating out of student is S. We are setting S, I mean student ID to be 100, and then we are creating a clone of this same student. And you can see here that the member to member copy is done. So that's what we are talking about member wise assignment. So there are other examples as well in your book. So go by the slides or the book, but those are the, I mean, the main, the essence of that particular feature we just described there in our code. So there are copy constructor as well. I mean, the copy constructors are special type of, we know the constructor, right? I mean, just let's clarify. You have a class, X is a class, and then you have something like X, and this is your constructor, right? So, and constructor should be public. There can be private constructor as well, but we are not going into that much sophistication as of yet. Now, copy constructors are a little different. They are special constructors that used when a newly created object is initialized to the data of another object of the same class. That's a very important stuff. What we are doing here, we are creating a new class, and then in the previous case, we have copied the class, cloned the class. In the member-wise assignment, we cloned the class basically based on another class. But here, we are trying to initialize the class based on the data of another object of the same class. So default copy constructor copies field to field. So every member, it's member wise. Now default copy constructor works fine in many cases. So let's see uh, what if object contains a pointer. Let's say you have this one. Class is the sum class public, and then you have this one, and then you say that value equals new int, and then pointer value equals value. So things are getting little complex here. So you should, I mean, we need to think about this. I mean, you can just go into your program and try to run it and see whatever is happening. I mean, with this code, if you have if you have something like if you encounter the the scenario of that kind, then what is going to happen with your code? That's something like your food for thought. Do it whenever you get a chance. So that's pretty much like your copy constructor stuff. So let's see, just a second. So there are multiple scenarios you could use for the copy. I mean, there are multiple scenarios in the copy constructor. The Let's go through that. So what we get using member-wise copy with objects containing dynamic memory. So that's another edge cases of the copy constructor. So you have something like this. Now you have this one equals this one. Then you know what you are doing, some class, whatever. You have instantiated that class with this constructor, with this initialization. Then you do the member-wise copy. Now you do object to set val equals this one. Now if you do object one get val, you will find the same thing. So what is going on here? Because since you are copying, they are basically getting everything from the same memory location. So that actually creates everything like that. So that's the reason you are getting that. So this thing, I mean, you can just simulate it on your Visual VS Code, and you can study what is going on in that case, and you will clearly understand uh, whatever is, I mean, whatever at stake. I mean, how you define the copy constructor and so on. So again, I say that it is basically some kind of edge cases. These examples are part of the edge cases. You will see that there are plenty of examples in your book. I'm just showing a glimpse of your book where you can just plug in your code and learn this one. So you see two pointers pointing to the same array, so you can get the same thing. So if you go there and they have some examples in the code, you can use these examples. And I mean, there are other examples as well. Just a quick glimpse for your reference. Now, you can have programmer defined copy constructor as well. It allows a programmer to solve problem with objects that contains pointer. So you have this one, you know, and then you have the value and then you use the pointer here. Now copy constructor takes a reference parameter to an object of the class, and then each object now points to separate dynamic memory. So you have some class this one, so then you have this one. So now what is happening, the object one, I mean, if you use it in this way, if you instantiate the class in this way, uh, I mean, basically you use the pointer in your constructor, then you should have, uh, unlike the previous situation, you should have this. Once you set a different value, each object should be pointing to a separate dynamic memory. Why? Because of this particular initialization of the value. So that's about it. Now you can, I mean, since the copy constructor has a reference to the object it is copying from, so you can have something like this. It can modify that object as well. That's pretty obvious, right? I mean, it has a reference to another object, so it can modify that object. To prevent this from happening, you can make the object parameter as constant. So you can make it a constant. That way, you cannot modify it. Even if you try to do that, your compiler will resist. It will not, it's not going to happen because of this constant keyword. So here you can modify this particular object, but in this case you cannot modify this object. You are only concerned in this case with the one you are creating. So I mean, there are examples given. I mean, you will find this exactly same examples in the book itself. where they illustrate all the scenarios with the copy constructor. So next topic is operator overloading. There are operators like plus, minus, division, uh, multiplication. There can be modulus operator. So it is possible to overload those operators. When do you use the overload? So these operators are applicable to only some primitive variables, right? I mean, integers or floats, you can apply these operators. What if you have let's say, you have a rectangle object, let us say, okay, rectangle object with your sides x and y. What you want to do, you want to add two rectangle objects. I mean, it's unimaginable, but let's say it is possible. So the formula of adding, it's of course defined by your use cases. Formula may be you are just doing x1 plus x plus x1. You are getting a new rectangle with following specification. Mathematically, x plus x1, it is very superficial. I'm just giving you some example. Y plus y1. You cannot add two rectangles in this way, of course. So if instead of rectangle there can be some function, right? You can say function of x and y, and the function is defined in a way that xy function x1 y1, if you add them together, you will get a new function which is basically x plus x1 y plus y1. So this is possible. I mean, this type of function is possible to create mathematically. So in that case, if you want to convert this mathematical equation, mathematical function into your program, you cannot do it by simple addition or subtraction. So you have to use the operator overloading. You can use some other situation as well. I mean, you can start by simply, let's say, let's see, just a second. So here, what you can do here, I mean, there are multiple ways of accomplishing the same goal. Let's say you have f1 xy, you have f2 xy. You can simply say define an add function, you know, and then with the add function you can say add f1. I mean, you can have some synt. I mean, I'm very pseudocode. I'm writing a pseudocode here. So you can add something like that and then create a function like that. And then you can say, suppose f1 is a class. So f1 dot whatever, f2 dot whatever plus. So basically you are adding f1, let's say x, y. You can simply define f1 dot whatever function f1 dot x plus x1, if f1 dot y plus y1. I mean, that is another way you can do defining explicit add functions. But this is some kind of boilerplate coding, meaning you have to write, you have to define, it involves defining and redefining your class instances, and it becomes complex at some point. So sometimes you may not want that. That's basically the situation. So, I mean, there can be another situation where you can have such an example. Let's create a new instance of the board. That way it will be simple. Yeah. There can be another example. Let's say you have 2 points in the space P1, okay, XY, another point is P2 xy. So in real world, you are defining a class called point. It's a class, and then within that class, you are defining int, assuming this is int x private, int y, and then you define the public functions and so on. So in order to get the distance between the 2 points, you cannot just do you cannot just do a plus or minus. I mean, in general, you would say uh, algebraically, it should be P2 minus P1, the value of P2 minus P1. But really, in the real world, you cannot just subtract x from this x, y from this y. Then you have to use that addition or subtraction function. Another way of doing it is to overload your minus operation, that is the uh, subtraction operator for this, so that it is applicable to this class. That's the scope of operator overloading. So the name of the function for the overloaded operator is operator. This is the syntax. You have to write the operator, and then you have to you have to include the related operator along with that. And then prototype for the overloaded operator goes in the declaration of the class that is overloading it, and overloaded operator function definition goes with other member functions. So um, I mean, there can be multiple examples. Let's see. I mean, in the book you have multiple examples. I will try to load a video with different examples, alternate examples with this operator overloading, because due to the shortage of the time, let's finish this one, the terminology and definition. Then we will come back. During the week, this week time, I will try to load some videos with specific examples of operator overloading. So another thing is the this pointer. This means this. I mean, you have an instance of the class, right? Let's say there is a class called P, and then you do P, it's instantiated as X. So whatever instance variables are there, I mean, these instance variable belong to X. So whenever you are in this object X, this refers to this object, this X, whatever is instantiated. Is the is a predefined pointer available to a class's member function. It always points to the instance. That's what I'm saying. It always points to the instance of the class whose function is being called. Now, this is passed as a hidden argument to all non-static member functions. So, for example, when we do this thing, like let's say here, um, where do we define this class? Let's say here. So when we do like this one, so when you do this one basically, the student ID, it belongs to the specific instance. So you should be able to write here the this function, you know, this is the basic notation. I mean, this means this instance of this class. So when you go there, you don't need to do any code change here. But if you compile it, basically this there is a problem. Student ID, this which is pointer type student, maybe you use this one. Oh, maybe we have to use that way. Just a second, let's go over there. What is going on? Test.h, test1.h, I'm trying to find out here. So maybe this you can do. So if you now try to compile it, it will compile. And if you run test1.cpp, um, what is going on? It's something bad happened. I don't know what happened. We will see. Oh, what is why I'm doing it here? I don't know what is happening. We'll take a look later. But basically, this is as I say it here. We have to do some more code changes there. But this is basically it says the this particular instance of the class. So I mean that student one, two are both student test core objects. I mean these are uh, this is a student test scores is a class. Student one and student two are both instance of the same class. So when you do that, you can get the get student name for this particular function if you can do that. When get student name is operating on student 1, this pointer is pointing to student 1. And likewise, for student 2, this operator will be operating to student 2. So, so basically the way you use these pointer, let's try to find some example for little bit more clarity. So whenever you use this, I will upload separate video for that because there is no time to write the extensive code. But you will find it in your textbook about the this pointer because it's basically it is basically pointed to the specific instance and you have to use the pointer instead of just making it very static as we did there. You should not make it static. You have to make it a little bit pointer, make use of the pointer. So next thing is the operator overloading. So that's what we were talking about. So you have the prototype like this. You have void operator equals. So that means you are overloading this operator equals operator and then equals operator and then you have this some class rval. I mean the parameter for object on the right side of the operator. So the operator is called via object on left side. So basically whatever object you are defining the operator, you have to use that operator via the object. So the example is something like this, object one. So let's say that object operator equals that is equals object two. So what you are going to do here? You are basically trying to add object one and object two. So that's why instead of doing object 1 plus object 2, it is impossible, right? Because you are this object 1 and object 2 are not primitive variables. They are objects. So that's why you have to overload the operator. So this is not plus, this is equals, of course, I'm sorry. So you can do object 1, you are overloading the operator and you make it to object 2. It can also used in more conventional manner object 1 equals object 2. I mean you can do that as well. For equality operator it is done because you know you are doing like I mean member wise copy. But for other operators it will be a little bit more complex than this one. So overloaded operator can return a value itself. So you have for example operator minus the exactly the same thing that we were talking about, some 2 points distance between 2 points. So you have defined this overloaded operator and then you have passed the reference to I mean that whatever right hand side is and then you are returning this one x minus right hand dot x whatever this right should be a an instance of this particular function particular class. So you have this one, then you have you can do it in this way. point you define these two instances, and then you can do point 2 minus point 1. So that way this operator minus is fetched into this particular conversation, and it will display this value. So again, when you define the overloaded operator, you define it inside the class in this way. You should write operator. This is the syntax. You should write operator and then what operator you are defining. So this one. And then you put some argument, appropriate argument, but it has to be a pointer. Then, I mean, reference. It has to be a reference variable. Then what you can do, you can define the formula of that operator. I mean, in this case, we are doing the minus, and the formula for minus is something like this. So then in the main function, what we are doing, we are creating two instances of the point 2D object. So x and y are defined as 2, 2 and 4, 4. So we are defining the distance between these 2 points. So when you are implementing using the overloaded operator, you are using simply minus, I mean simply the basic operator, because you have already defined it within your own class. So you do point 2 minus point 1, and then what is going to happen whenever you do it in the context of point 1 and point 2, this will know that this operator is overloaded here, and it will find out the difference using this formula, and it will give you that difference. That's the overloaded operator. So return type should be the same as the left operand. So basically, the return type of this particular this one, whatever, I mean left operand double, it should return the double. That's the point. So that's the basic I mean definition of any function itself. Now you can declare the function in this way. You have a constant some class operator equals, and then you can define the function in that way. Like here we define the function in this way. So that's the way you should be defined. And in function include as last statement return this. You can do that. So in this case, it is done in a little different way, but you can, whenever you define a value in function, you can include as last statement, you can do return point at this. So it can change the meaning of an operator. That is very important. Uh, I mean, plus needs to be plus, but plus can be primitively plus is the sum of two numbers, but in this case, it's a different formula. So it cannot change the number of operands of the operator, first of all. Only certain operators can be overloaded, not all. You cannot overload the following operators like, I mean, this one, point, star, I mean, that way, uh, to the power star actually. So this operator, size of operator, you cannot overload. So overloading types of operators, I mean plus plus and minus minus operator overloaded differently for prefix versus postfix notation. So you have to do appropriate like you have to use the appropriate formula for overloading different operators. I mean if you use it in for the prefix, you have to define the behavior. Whenever you are overloading something, you are the responsible as a programmer to define the behavior. That's why sometimes people find it easier to add explicitly add function or subtract function, division function, whatever it is, make it the member function of the class and go with that. Sometimes people choose that over defining the overloading the operators. So you can do the overloaded array operator as well. You can create classes that behave like arrays, provide bounds checking on subscripts, but you must consider constructor and destructor. So that's, I mean, this one returns a reference to the object, not an object itself. So you can convert the object. I mean, it depends on the type of the object that can be converted to another type. Automatically done. It is automatically done for built-in data types. It must write an operator function to perform the conversion. Now, to convert an this object, feet inches object to an int, feet inches to an int, basically what you have to do it in this way. Um, like you have to define something like that. So you are basically converting an object into a primitive type. You have an object here. Feet inches is an object. You are converting to a primitive integer. So you have to return the appropriate integer for that. You know. So assuming distance is a feet in inches object, it allows a statement like int d is equal to distance because you are using this, I mean this integer operator. You are converted the integer operator. These are again, these are all the usage of the advanced operations with a class. This has to be taken care of with very careful, I mean with utmost care. It requires a lot of coding practice. So I recommend, I mean, after this class, go to the book, find out all the examples and try to solve them yourselves. That will give you the best option to learn this, I mean, complex. It's not complex, but these are really advanced operations with the classes. You can have the aggregation. I mean, it's a aggregation, a class is a member of a class. So you are basically composing different class together. So I mean it's like this one. Let's say you can do like a different, a class is a member of class means let's say house is a class. Okay, you are defining a class house. There is a class called window. Okay, there is a class called door. Now you define the class house as this way: private, and then you say window w, door d. So your instance variables are basically the classes. So far we have considered instance variables to be some primitive variables, but now we are using instance variable as different classes. So it supports the modeling of has a relationship. So a house has a window, a house has a door. This kind of dependency. I mean, it models that type of dependency and some notation as for structures within the structures. I mean, you have the same notation. I mean, you have, if you define a struct, it can be defined as the struct inside the struct. So basically, it is quite understandable if you think about simple class. Like you have a class which has two member functions, both are integers. Now you have int and int, those are the primitive variables, but now you are using the classes. The classes are not primitive variables, these are complex, more complex variables, rather user defined variables because you define the classes. So you can build a second, I mean, you can build a new class out of some existing classes as well. So this is basically called aggregation in the context of your programming. So here in the same way, I mean you have the this one, the student info. This is your student info class, right? Now inside the student you can define it in this way. So this is a great thing because you know you are composing a lot of, you are doing a lot of aggregation, you are composing a lot of like member functions within the wrap a lot of member functions within this student info class, and you are handling these member functions all together because they belong together, right? They are always together. So I mean the I mean basically you have the some instructor textbook and course classes in chapter 14, if you go through your textbook, you will find that course, I mean, you have the instructor, you have the textbook, but then the course object, the course class uses the instructor uh, class and the textbook class separately. So a course has an instructor, a course has a textbook. So that's the relationship it is trying to utilize here. So there are more to it. I mean, there are temporary values. Let's so so temporary values. You can consider this one square. You return a dot a star a, and then you do x. Then you are computing the square. So square function is called, and the value 5 is passed as an argument. The square function calculates 5 times 5 and stores the result as 25 as a temporary value. You know, the temporary value is copied to the variable x here. So it's basically this one, when whatever square function computes, this is a temporary value. It is assigned to a more permanent variable, and then the temporary value is no longer needed. So here, once it is assigned to this one, the system discards that temporary value. So that's it's simple. You have done it many times while coding, but this is the terminological explanation of these steps. There are two types of values stored in memory during execution of a program. So L values and R values. So values that persist beyond the statement that created them and have names that make them accessible to other statements in the program. These are called the L values, the values that are temporary and cannot be accessed beyond the statement that created them in C++. They are called R values. So we have two types of temporary values, L values and R values. These are all terminology, good for your quizzes. So there are references we can see here. So here, I mean, particularly when you do the swap, I mean, all these things, you use those temporary values. Uh, I mean, basically, you are using some temporary bucket to store some variables, and then once you reassign those temporary values to the actual variable, then the scope, those temporary variable goes out of scope. So, I mean, there are some other situations you can find here. I'm not going through each one of them, but there are different, I mean, context. Those are, I mean, you should go through the book and find the terminology. You don't need to write a detailed code around this. If you can go through the terminologies, you should be good for this course. Some simple definition would do the best thing, because these are very advanced operations. We will do some little bit programming whenever in the context of programming. We are not going to use very detailed. You will not be tested for detailed knowledge about these different edge cases. Some simple examples, simple terminological knowledge should be fine. So I guess that's all we had to discuss today. And now we are, I mean, little bit over time. Still, if you have any question, this is the time to ask questions. Well, if not, then I will talk to you next week, and within this week, I will try to upload some videos, find out some videos related to operator overloading, and we will go from there. Thank you for joining the class today. Yes, I mean, you can resubmit the lab, of course, yes. So long as they're open, you can resubmit. Right now, there is those are open until your final date. So after June 3rd, you cannot resubmit anything, but before June 3rd, all the homeworks are resubmittable. Thanks for asking. Good questions. Okay, then talk to you later. See you in the next week. Bye.